Students, in this lecture, we will be learning about essential fatty acids. Please remember, anytime we refer to essential nutrients, we are talking about nutrients that must be provided with foods, simply because the body is unable to synthesize these nutrients. You know that this implies that some nutrients the body actually synthesizes, which is actually the case. But when it comes to specific fatty acids, we are unable to do so, okay? We have already discussed the structure of essential fatty acids, but I will briefly review it one more time. We will also look at metabolic pathway, how the longest essential fatty acids are synthesized. We will list dietary sources, and then we will discuss the health effects of these fatty acids. Chemical structure of essential fatty acids. Remember, fatty acids are composed of a chain of carbons, to which we have a metal and a carboxyl or acid group attached. Okay. Here we have an example of the omega-3 and the omega-6 fatty acids, and you should already remember that since the double bond, the first double bond here, counting from the omega carbon, is between the third and the fourth carbons in the structure, this is the omega-3 fatty acids called the alpha-linolenic acid. Okay, this is the omega-6 linoleic acid. Okay, when we look at the metabolic pathway, we mentioned that the alpha-linolenic acid, for example, is the parent of the other fatty acids from the omega family, because this alpha-linolenic acid can be used to derive the other ones. Okay, and here we have the omega-6 fatty acids listed, and the linoleic acid is the parent one. Now, even though I listed a number of these, those highlighted here are those that I would like you to remember. And remember the eicosapentaenoic and the docosahexaenoic acids, you can simply remember as EPA and DHA. I want you to remember these because I consider them the most important when it comes to our health effects, of which I will be shortly discussing. I want to also mention that in nature, the vast majority in terms of the quantity of these fatty acids come as cis form, or they have a cis form. Cis form meaning that the hydrogens that are actually attached to the two carbons that form the double bond are on the same side of the chemical structure. In contrast, we have trans fats or trans fatty acids, and the difference between cis and trans fatty acid is that the hydrogens rather attached to these carbons that form double bond are on the opposite side. As a result, they have a little bit different shape. Okay, so this is, you can see the shape of the cis fatty acid. The trans fatty acid has a slightly different shape. As a result, also, the cis fatty acids are oftentimes beneficial. The trans fatty acids are detrimental. It all has to do with the chemistry of these fatty acids. Let's look at the dietary sources of essential fatty acids. Remember again that we have to ingest them from foods. And here we have an illustration. Please remember that the alpha-linolenic acid is the only fatty acids from the omega-3 family found in plant foods. And flax seeds or flaxseed oil is actually the best source of any known sources of alpha-linolenic acid. However, we do not find any of the other fatty acids from the omega-3 family in other plant foods, with the exception of seaweed or algae. Okay. On the other hand, fish and other marine creatures contain not only alpha-linolenic acid, but contain eicosapentaenoic acid and docosahexaenoic acid. The same goes for supplements derived from fish and other marine products, as well as supplements derived from algae. Okay, these supplements, those derived from algae, are suitable for vegetarians, for example, or vegans who don't want to use any animal products. In fact, I am one of those, and I use supplements of EPA and DHA from algae. In the market, they may be labeled as algae derived or seaweed derived or vegan, quote, fish oil. Okay, they're not fish again, but they would contain the same profile of EPA and DHA. Now, in order for us to secrete any of the derivatives of the parent fatty acids, whether from the omega-3 or omega-6 family, we need enzymes. And these enzymes are called elongases and desaturases. If you scroll back to previous slides or slides from the previous lecture, you will see that EPA is longer than alpha-linolenic acid, and DHA is still longer than EPA and longer than alpha-linolenic acid. And so additional carbons are added to alpha-linolenic acid in the process of making EPA. And this can be done because we have these classes of enzymes we called elongases. Furthermore, if we count the points of unsaturation in alpha-linolenic acid, we have 3 points of unsaturation, or 3 places in which we find the double bonds. But when we look at EPA, we find as many as 5 points of desaturation, and 6 points of desaturations are found in docosahexaenoic acid. And this can be done because of desaturases enzymes. Okay, so these are the enzymes essential for metabolism of these essential fatty acids, EPA, or rather omega-3 and omega-6. Another important information that I want to share with you is, even though I mentioned that we can derive EPA and DHA from alpha-linolenic acid, that you can find this in different articles, in different textbooks. Theoretically, this is possible because we have desaturases and elongases, these enzymes that are supposed to be used to derive DHA. Practically speaking, this finding here from this research that I have here on the slide showed that as we ingest alpha-linolenic acid, here represented on the vertical axle, the more of the alpha-linolenic acid we ingest, the higher the amount in the blood. The same goes for EPA. The more alpha-linolenic acid we ingest, the higher amount of EPA in the blood. However, the amount of alpha-linolenic acid ingested has no impact on blood DHA. That's what's illustrated by this broken line. Okay, and so in reality there is no synthesis of DHA, and that's why I consider DHA the most important of these enzymes, because we just absolutely have to provide them with foods. On the other hand, when we ingest supplements that contain both EPA and DHA, as you can see illustrated on this graph here, both EPA and DHA increases in the blood, which is what we want to achieve. Okay. All right. Even though the best source of EPA and DHA, these very important essential fatty acids, are fish and any other marine animals, I don't know if we can actually recommend a lot of intake of fish and seafood. This is why. Notice fish fraud. Something fishy is happening with the labeling of seafood. And this quote implies that more than 50% of the times when you go to American restaurants or buy fish from a grocery store, you may get something that you didn't order. You may order salmon, for example. You may get something other than salmon. This is because fish is mislabeled, and oftentimes cheaper fish is sold for higher price as a different type of fish. Now, what this also means is that you may think you may get a fish that has high content of these essential fatty acids and or low content of contaminants such as metal mercury, for example. In reality, it may not be so because, again, more than 50% of the times we have adulterated product that is being sold and something other than what it is. And so instead, my recommendation is to use, notice here, plant-based or vegan or algae-derived omega-3 fatty acids that contain EPA and DHA. They don't contain a lot of toxins, but they contain the same fatty acids and can help with achieving the health benefits associated with ingesting of these fatty acids. The essential fatty acids EPA and DHA are so important for our health that scientists actually introduced an interesting concept, which I would like to introduce to you. It is called the omega-3 index. I want you to remember the definition of the omega-3 index, which I will give you in a moment, as well as categories of the omega-3 index, okay? Let's begin with the definition. The omega-3 index refers to the amount of fatty acids called EPA and DHA as percentage of total fatty acids in red blood cells. We can actually measure these fatty acids in what we call adipose tissue, which means in fatty tissue or in body fat. We can measure them in the blood or in serum, okay? We can measure them in red blood cells. So the omega-3 index specifically refers to the amount of EPA plus DHA as percentage of total all fatty acids found in red blood cells, okay? There are three different categories of the omega-3 index. Number one, undesirable or simply low. That's if your percentage of EPA plus DHA is less than 4, okay? And then intermediate or medium between 4 and 8, and then desirable or high, 8 and above. You can see here on the slide 8 to 12, this is because most people who are in the desirable or high category of the omega-3 index have somewhere between 8 and 12%, but it is actually possible to have it higher than 12%. Again, that's percentage of total fatty acids. And the reason why we call them undesirable and or desirable is because those individuals with the desirable intake, rather a percentage, have better health outcomes, okay? And those in the undesirable zone have the lowest or the worst outcomes, such as cardiovascular disease, Parkinson's disease, dementia, other health effects to which these fatty acids are actually beneficial. Speaking of health effects, let's list at least some of them, okay? Notice this quote: consumption of 250 milligrams of DHA and EPA per day from either dietary or supplement sources should be part of management of primary or prevention of coronary heart disease death and after a coronary event to reduce the risk of coronary heart disease death. And so these fatty acids are important in prevention of cardiovascular disease. In fact, when we look at their impact on the vascular system, notice, for example, what happens as we age. I have several changes outlined here, but an important one is we do not secrete as much of nitric oxide, a compound called nitric oxide, as we become older as when we were younger. As a result, we have stiffer and thicker arteries. we have what we call a platelet aggregation effect, which means that platelets, blood cells called platelets, stick together, okay? And as a result, we have increased systolic and diastolic blood pressure. But when we ingest adequate amounts of EPA and DHA, we can increase the synthesis of nitric oxide, okay? We can decrease the stiffness and thickness of arteries. We can have anti-aggregating effect, which means that the platelets will not stick together. Furthermore, we can also keep the arteries elastic, all of which will help with decreasing systolic and diastolic blood pressure and reducing risk for cardiovascular complications. Notice, for example, a result of this study. This study is known as the Adventist Health Study 2. And here we have a comparison of death from all causes, ischemic heart disease, cardiovascular disease, and others. And notice who was the winner here. Out of the different diet groups, people represented, or people who consume different type of diet, pesco-vegetarians had the lowest reduction of all-cause mortality or death, by far the lowest reduction, minus 35%, lower risk of dying in comparison to non-vegetarians from ischemic heart disease, 20% lower from cardiovascular disease. EPA and DHA fatty acids can help in the prevention of dementia and Alzheimer's disease. I don't have time maybe to discuss all details, but this is a analysis based on many studies and many individuals. And notice that just 0.1 of a gram per day of DHA reduced the risk of dementia by 14% and Alzheimer's disease, AD, that's Alzheimer's disease, by 37% in comparison to if we were not taking any of these fatty acids, or this fatty acid. Here we have another study. And what was found was that adding DHA to individuals' diet resulted in increased hippocampus volume. Hippocampus is a part of the brain in charge or responsible for short and long-term memory. And so this supplement or these fatty acids will help with preserving cognition and reducing, again, risk of any type of Alzheimer's disease, dementia type of symptoms. There are many other benefits of ingesting of these fatty acids, but I only have time to discuss these two. Thank you.